Hey everybody, Longo here, and in this video we are going to cover circles, which are one of the four conics that we're going to be talking about. Circles are pretty easy to work with. All you need is a center and a radius, and you're good to go. So the standard form equation of a circle is x minus h quantity squared plus y minus k quantity squared equals your radius squared, where h and k are the coordinates of your center. Similar to other things we've worked with where it's like opposite of the inside. So when you are given an equation in standard form, it's very easy to work with. However, now and then you are going to be given the equation in a general form where everything is kind of mixed together. Now, there are a few ways to work with these, but the best way to do it is to put it into standard form by using the completing the square method. Now, one thing you should be aware of is as we get through four different conics, it's how to identify which conic you are going to be working with before you actually do anything. So we're going to be talking about circles, ellipses, hyperbolas, and parabolas. And a circle's general form, you can tell it's a circle because you have two positive squared variables, and they have the same number in front. So usually it's just x squared and y squared. But every now and then it could be something like 2x squared and 2y squared. Okay, so they have to have the same coefficient as well. So if you see x squared, y squared, both positive, both squared, same number in front, then you're going to have a circle. Okay, now right now that doesn't seem like anything too crazy, but once you get to ellipses and then hyperbolas, you will understand why you need to know what you're working towards. Okay, so how do we do this? Well, back in the day, you learned how to complete the square. What you have to do first, though, is you have to rearrange this where you get your x's together, your y's together, and your constants on the other side of the equal sign. So we're going to do that first. We have x squared, and then plus 4x. And then we're going to have y squared minus 6y. And then we're going to have that equal to a negative 4. Okay, so again, get your x's together, get your y's together, and then put your constant on the other side. And now you're going to do that completing the square trick that you learned back in the day. So how you do that is you take half of the b value and square it. So we have x squared plus 4x plus half of 4 is 2 squared is 4. But you also have to add that to the other side as well. And then you do that again with y. So you have y squared minus 6y. Half of 6 is 3 squared is 9. So we're going to add 9 here. But we're also going to add 9 to the other side, okay? And then the last part is when you wrote it in parentheses and you have your x and half of b, which is plus 2 quantity squared. And then you have your plus parentheses y minus 3 squared. Again, it's y and half of your b value. And that's equal to negative 4 plus 9, which is 9. And you are done. Circles is the easiest one to take from general form to standard form. And now all you need is the center and the radius. So your center is opposite of the insides, so h and k. So we have a negative 2, comma, positive 3. And we're just going to go to negative 2, positive 3, and you just put a dot. That's your center. Now, your equation says it's equal to r squared. So if you would prefer, you can write 9 as 3 squared. It doesn't matter. But you need to know that your radius is 3, not 9. And now all you have to do is go 3 units to the right, 3 units up, 3 units to the left and 3 units down, because in a circle, radii are always congruent in every direction you can possibly go. And now you are done. That's how you graph a circle. Now you can also work backwards. You can write equations from a graph or given information. So here are 2 different examples. The first one should be really easy for you to do if you understand how you just graphed that last circle. So you can probably just try this one right now, but basically all you need to know is your center and your radius, which you have, and then you just plug it into the equation. So we would have our x squared, our y squared equals our radius squared. Our center is at a positive 5, negative 3, so that would be a negative 5 and then a positive 3 inside of the equation. Remember, it's opposite. Our radius is 1, 2, 3, 4, so 4 squared would be 16. And again, if you want to write 4 squared, that's fine. So that's a very easy thing to do. This next example, it giving you a center, so you already know that this is going to be x plus 3 squared plus y minus 5 squared equals our radius squared, but we don't have our radius. But we do have a tangent. Now, in case you forgot what a tangent was, a tangent is just a line that touches the circle once. So if we know where the center is, and if we know where a tangent is, all we have to do is figure out how far away we are from the center to the tangent. Now, you can do this a couple of different ways. This says y equals 7. The y coordinate of your center is 5. So how do you get from 5 to 7? It's 2. So your radius is 2, which means over here it's 4. But if you don't want to think about it that way, you can just use a graph. So I didn't provide a graph for this example for you because I wanted you to just think about it. But you can always just go to negative 3, 5, and you can put your center, and then you can graph your horizontal asymptote, and you'll see that you're 2 away. Not horizontal asymptote, your tangent, that you're just 2 units away. So if that was a tangent, it's going to look something like that. But again, you didn't even really need all that. All you needed to do is know that since it's y, 7 is 2 units away from 5. That's it for circles. This is Longo, and I'm out. See you, bye.